Tim was not excited for Ed puzzle assignments, and that I don't care. All right, Ed puzzle is something that kids don't like for some reason. Teachers love because it does stuff for you. I will show you what you need to do. Now, first off, the way the Ed puzzle is set up in this class, you can do it straight through Canvas. You don't have to have an account with Ed puzzle. When you come to Canvas, hopefully you're used to it now, you land on the module page, right? We're now in chapter 4. And if you look towards the bottom, you have predicting solubility of ionic compounds, Ed puzzle assignment. I think that's 7 minutes long. And then this one's 5 minutes long. I know, and you can't. I introduced Goddard to this. So better. All right. So you just click on it. You can do it inside Canvas. You don't have to have your own Ed puzzle account. There'll be a video for you. It won't let me show on my side, even if I go to student view, whatever. There's a video you play, it will pause and ask you questions. Or the first one, just mostly it tells you things to do, like, hey, write this chart down in your notes. That's all it's doing. Okay, yeah. They are. You can do that, and then I will give you the amount of points that you deserve. Okay. Which is 0. Okay. These are supposed to help you. I don't know. I'm going to put them on your grade because you just don't like doing stuff that's not on your grade for some reason. I can't figure it out. All right. So that's what those are. Those are due by Friday. It's 12 minutes of your life. Now, it will really take you 20 because it will pause a few times and ask you questions. But it's not awful. Okay, the plan for today, we already did electrolytes, so it's really just precipitate reactions. All right, that's a new term for you, maybe. A precipitate, it's precipitating right now, like rain's falling, right? The precipitate's a solid that's formed when two things react and goes to the bottom. You've seen a precipitate in this class before. You turn to your partner and say, hey, this is when I saw two things react to form something solid that went to the bottom. All right. Okay. 3, 2, 1. Back with me. So it was what? I heard it. The copper lab. We had that light blue stuff. I put in the clear stuff and it made dark blue stuff. Very complicated words here. Then we heated it and it turned to black stuff. It still went to the bottom, right? Those things were called precipitates. All right. These are also called, oh, that's way too. These are called net ionic reactions. Oh, we got a woo from the back. These are not hard, and they are always on the AP test. So it is something I can tell you that will be on the ACT. You know what I mean? The AP test. They will not be on the ACT. All right. I don't know. They won't be. All right. So understand and describe an electrolyte. We did that yesterday. So will you, don't go too crazy, but in 30 seconds, describe to your partner what an electrolyte is. Ready, set, go. All right, 15 seconds. Yeah, you can burn it. Okay, here we go. Back with me in 5, 4, 3, 2, 1. All right. So it's something that dissociates to produce plus and minus charges that makes a liquid conduct electricity. That's a long answer. You probably said something like that. You good with that? So as long as you can describe what an electrolyte is, you're good. Now, be able to predict and write out, sorry. net ionic equations or reactions, whatever you want to call them. The video, both videos will back this up a ton. So if you want to know it the best, I would watch those videos today, because I'll teach it, we'll go over it, and then that will reinforce it. Okay, so here we go. You do not have to write this down, because you're going to write it down in the video. Not all of it, but you will also be given a chart on your test that looks like this. Let me see if I have one right here. Yep. In 2013, they removed the requirements for you to memorize the rules for solubility. That one's gross looking. So you get them on the AP test, and I will give them on my test. So you don't have to write this down, but in case you care. Strong electrolytes are compounds that contain these things. Now, chemistry is one of the hardest sciences because there's so many exceptions to like every rule. So you'll notice there are only two things that have no exceptions. That means anything with NO3 in it will always dissociate. Go ahead.
Are you sure there's not?
There might be, but anything within reason that we deal with, there's no exceptions. Okay, so nitrate and acetate, they never reform with anything in solution. So what that means is that nitrate and acetate are really attracted to water, not the other thing they're with ever. It'll dump them quick and be pulled apart by the water. Okay, next, these things are mostly soluble except for when we have chlorine with silver, mercury, or lead. Bromine, silver, mercury, or lead. Silver, mercury, or lead. These things right here, silver, mercury, and lead, these should be your red flags. If you ever see that in a problem, you're like, oh, I got to double check. Okay, that's where they're trying to figure it out. And then SO4 is strontium, barium, mercury, and lead. All right, now these things right here are typically insoluble, meaning these are always going to be in the precipitate, except when they're with NH4, Ca+, SR2, Ba. NH4, family 1. NH4, family 1. Family 1, NH4, Ca, whatever, all that. Do you see anything in common right here? NH4. All right. These are all anions, but mostly the cation NH4 is pretty much always soluble. So anyway, you don't have to have this memorized. You have to like apply it. So you'd be given a reaction and asked what the precipitate was. And so you'd have your reaction and it'd be like, I don't know, silver nitrate. Okay, so there's a red flag in there, right? Silver, but then there's nitrate. So this thing will always be aqueous. Right? Then if a reaction is going to happen, I better include something that has one of these ions in it, right? Or no reaction would happen. Okay, so for just a second, pretend I put silver, nitrate, and lead acetate. If I put those two compounds together, does anything really react? When we say react, we mean do they stick together in the solution? And the answer would be no. There would be no reaction here because NO3 will dissociate from silver when placed in water, and NO3 will not hang on to lead when placed in water, and acetate will break up with lead and it won't reform with silver either. So nothing would happen in this. There'd be no reaction here. Okay, but if I put something else, like just a standard like NaCl, Is NaCl aqueous? We would check these rules. We'd say, all right, I have Cl minus on my list right here. It is always soluble except when it's with one of these three things. In NaCl, is it with any of those three things? No, it's not, right? So these two are aqueous. But tell your partner over here what two things are going to hook up. All right, in this reaction, we're going to have all four of these things in a solution. Two of the four are excited, and they're going to hang out together from now on, and that would be who? Ag is going to bond with, it's going to go with the Cl. Why would it go with NO3 again? It wouldn't. Why wouldn't it go with Pb? Or sorry, I got rid of Pb. Why wouldn't it hang out with Na? They're both metals. They're both positives. They repel each other. So what happens is Ag finds Cl, and they are attracted to each other more than they're attracted to water. So they form a precipitate. And then we would have what's left over is Na plus and NO3 minus, not hanging out. They're the spectator ions. Okay, this chart, we'll use it over and over to figure out this process. All right, so here we go. So a precipitate reaction is when one mixes ions that form compounds that are insoluble. So you have things that are all soluble. They've made solutions. They could be a color, like they could be a blue, a clear, yellow, whatever solution. But when you mix them together, they form something that's not in solution. It produces a solid. It goes to the bottom. And we had that. Remember our centrifuge? We were just speeding up the process of the precipitate moving down to the bottom. That's all we did because it's more dense. So it goes to the bottom. So precipitate reaction is when soluble reactants produce a solid product. They're very colorful. You'll see a ton of precipitate reactions tomorrow. Okay. When we haven't talked about it a ton, I don't know if it's on a slide or whatever. Is it here? I'll come back, I promise. All right, let's just talk about this real fast. Let's talk about these little things I've been writing now. So AQ, S, G, and L. That's dumb. All right. From now on, when we write a reaction, we will indicate the state of matter. Now that's tricky. Aqueous isn't a state of matter, but in reactions, we just kind of treat it like it is one. So AQ means it's aqueous. And that means it is dissociated. And that means it's in ion form. Like, I know that's a lot of stuff, but that's all, it means the same thing. Okay, S means that my product or reactant is a solid. And in what we're doing right now, a solid in this type of reaction, we'd call the precipitate. All right, pretty easy guess here. What's G? A gas. And for now, like for today, we won't probably have any gases, but that's common. And L then? All right. Now, you got to know that aqueous and liquid are very different. So if I were to write NaClAq, that means it's just salt water. If I wrote NaCl liquid, that would mean molten salt. That'd be like 3,000 degrees. It's a little bit different, right? So don't confuse aqueous and liquid. The most common liquid that we do is H2O. H2O will never be written as aqueous because that's what causes it to be aqueous. It's always a liquid. Okay, now H2O in some reactions is a gas. And we don't usually ever say it's a solid because we don't do most experiments below the freezing point of water. All right, so when we talk about these things, these reactions we've talked about, aqueous, dissociated, aqueous, dissociated, solid, formed a precipitate. And then if it has a plus and a minus, that means it's in the ionic form. You can put AQ if you feel like it as well. We're going to get rid of this way of writing it pretty soon anyway. Okay, so precipitate reactions, the state that the products and reactants are in. So let's dive in here. All right, metathesis or metathesis reactions, or I call them double replacement reactions. Now, we've been doing these. I've talked about them a few times, but I haven't exactly described them. In a double replacement or a metathesis, metathesis, whatever you want to say, reaction, means to transpose or to change. What happens in these reactions is the metal typically switches partners. So K will come over here and AG goes over here. You just cut the front off and move it and exchange them. If you've ever been like four-square dancing, it's just a do-si-do, right? Or it's a double date where all four of you realize it'd be better if you just hooked up with the other person. It happens. My wife's best friend married a boy that was on the other half of a double date. So it does happen. All right. So you'll see on the right side, AG is now hanging out with Cl and K is now hanging out with NO3. You with me? So what we would do now, we would know these were aqueous because silver, I shouldn't say silver, and that, I could say it that way, but I'll say it. NO3, finish the sentence for me. NO3 is always soluble. So that means that this is always aqueous. But it really means if this is aqueous, are Ag and NO3 together? No. So this is really a misrepresentation of what's really going on. If it's aqueous, it's really the silver ion and the nitrate ion in this solution. You with me on that? Okay, then K, we know Cl is always soluble, except for when it's with silver, mercury, or lead. Is K one of those three things? No. So this is a misrepresentation too. Inside this beaker, K and Cl are not together. They're hanging out apart. So K plus Cl minus. That's what's really in this beaker before all the action starts. You with me? Now this says it's solid. Will you tell your partner, and it's okay if you don't know right now, will you tell them how you would know that AgCl is the precipitate? All right. Good job, Gabe. There you go. All right. So looking right here on our solubility rules chart, we would know chlorine stays apart, except when it's with one of these three, and it's with silver. So we would know this is the precipitate. So since this is solid, inside my beaker, there literally is some AgCl that's stuck together. Then I know NO3 never forms a compound. So I have K plus, K plus, I should say, plus NO3 minus. You okay with that? Okay, let's introduce some words here. This, we'll do it this way. This reaction right here, written this way, is what we've done all year so far. This is called the molecular reaction. You've probably noticed I keep saying reaction and equation. I mean them the same. I'm sorry, I'm weird like that. So this is the molecular reaction. This right here, where everything's written out as ions or precipitates, it has a name. It's called the complete ionic reaction. Okay. Now, here's the deal. And it makes things easier. In the long run, once this clicks, this makes it way easier. If you look at the complete ionic reaction, is there any species that's exactly the same on the left and the right side of the arrow? Seth, you're nodding your head like, yeah. What is exactly the same? All right. K plus is K plus on the left and the right. So did anything happen to it? No. Good job. And then he also said the NO3 is NO3 minus on the left and NO3 minus on the right. So inside this beaker that this reaction happened, did anything happen to K and NO3? No. So we call them spectator ions, and we really ignore them because the reaction never happened. So we have a third reaction that we're going to write. It is Ag plus Cl minus, and then my arrow is AgCl solid. And that has a name. Anyone use context clues or foreshadowing and know the name of that already? No, it is a precipitate reaction. That is true. I think someone mumbled it. This is the net. Maybe you didn't. I tried to give you credit. This is the net ionic reaction. Now notice these two have a similar name. One is the complete. That shows every single thing in the beaker. One is the net, which shows you what actually happened. Because really, K and NO3 didn't do anything. Yes. All right, I'll write it. That's a good question. These things right here, K and NO3, are called spectator ions. Yep. Spectator ions are the species that are not part of the precipitate or part of a solid on the left. It's a little tricky, but they're the ones that don't change at all in the reaction. Okay, this is the goal for today. Now, I'm not just going to move on. Yep, that way. Okay, yep. We'll do a few of these. All right. I'm going to go and write another problem, but I'll do it on the solubility chart. Are we okay with that? Right here. So what we're going to do, we're going to write the molecular complete and net ionic reactions for the following mixtures when I put them together. Sound fun? All right, so I'm going to take potassium iodide, and then I'm going to add mercury 2 acetate. All right, then I want you to take a minute with your partners and see if you can come up with the molecular reaction here. And it's just a metathesis or an exchange. So K and Hg switch places, that's all. All right. And then you're complete, and then your net ionic. These take a little bit of time. So let me give you 4.5 minutes. I'm going to pause this, make sure I unpause it again. All right. Now, before I do this, AP Chemistry, it doesn't directly relate to your lives very often. And I'll be honest, neither does this. But I want you to think about why this stuff is very good for your brain and very good for your ACT. And I mean ACT this time. These problems require multiple pieces of information that you have to put together in an input format to come out with a specific thing. Your whole life, and usually the harder the problems, the more you get paid, unless you're like a professional athlete or actor, whatever, I don't know. But like an engineer or a lawyer, they have to take tons of information, synthesize it, and come out with reasonable answers. This is an exercise in that process. The AP or the ACT science section, there's no science on it really. There's synthesizing data, numbers, and text to come up with reasonable answers. So this is some point where honestly things can really help train your brain. So really try and work on these. You're never going to have to do this again, most of you in your lives, to just do a net ionic, but the process that your brain has to go through, you'll do a lot. Okay, I'm going to put it on a different page here. So we have Ki, and that is aqueous. It is aqueous because iodide is always soluble. That's what this table tells me, except for these things, and K was not one of those, right? So that means Ki is aqueous. Plus, I had lead 2 acetate. Hg, thank you. My bad. Just, yeah. Oh, that's what I get for trying to be different. Hg, so mercury 2 acetate. All right. Then I just switch the front partners, right? So K is now hanging out with who? I don't like the sound of that cough, Melissa. We're good. This is an N95 jacket, so I'll be fine. Okay, so no pun intended. So K is hanging out with who? Acetate, right? So C2H3O2. Now, let's be honest here. How many of you went like this? Yep. You're not alone. A lot of people. Let's, oh my laws. I'm teaching from the hall. Okay, are we ready? So this is a really common problem that all you cough by me. Look right here. This 2 belongs to Hg, right? You can hear me, right, Timmy? Can you hear me now? All right, this Hg, this 2 is really, it belongs to Hg's partner, not to acetate. Okay, it's like acetate is dating lead, so lead lets it borrow its car. I keep saying lead, but I need mercury. But after they break up, do you still get to borrow their car? No. Mercury's other girlfriend gets to borrow the car now. Okay, so what? You guys never broken up with anyone before? Okay, fine. Oh, good call. Good call. All right, where in this room is not a biohazard? Probably over here. Okay, here we go. So what's the other partnership here? All right, Hg, who is a +2, right? And what else is left? Iodine, which is a +1, so it's HgI2. Who had that part right? If you don't, then fix it. All right, good job. Now, here we have, oh, I never did this part. This was aqueous right here, correct? Because acetate is always soluble. Okay. And then HgI2, is it soluble? No. Iodide, right here. Iodide is usually soluble, but it's not with mercury. So there's your solid. You with me? So that's my precipitate. Okay. Oh my gosh. It's not just her, it's everywhere. Like while I was sitting there, I got an email. It says the following. It says, and this is after 2 ambulances came to the square mile of religious boundary I'm in charge of. Hold on, last night. Here we go. So-and-so woke up at 6, completely incoherent. He was speaking gibberish, couldn't dress himself, yada, yada. I took him to the emergency room. He has COVID. And then Alyssa barks all over me. My drivers this morning trying to kill me. The people in my ward going to the hospital last night. Everyone is, be careful. That's all I'm saying. Okay. So we have this so far. Everything that's aqueous, I'm going to break up. You okay with that? So I have K plus I minus plus Hg plus 2 plus 2 C2H3O2 minus, and then I have my arrow, correct? Now, if you put the right side in the other order, it doesn't matter. The order doesn't matter. Okay, I saw a bunch of people do something. What did I do here that was different than what you did? The 2? Okay, do you know where the 2 came from? Raise your hands if you know why there's a 2. Okay, the subscripts have to be accounted for in your net ionic. Corbin.
Why don't you put a 2 but a Ki?
I can balance it first, or I can balance the net.
So at the end of the day, we have to do that, or?
At the bare minimum, you have to balance the net ionic equation. You can balance the top and the middle, but the bottom one's the only one required. You okay with that? And the bottom one's shorter, so I usually just wait until then. All right, then I have my K plus C2H3O2 minus, and then right there you're like, wait, that's out of balance. I know that, we'll figure it out. All right, plus I'm left with HgI2 solid. I leave it together because it's the solid, or tell your partner what word we learned today. Precipitate. Precipitate. Okay, So who had that right? I know I haven't balanced it yet. I'm not being stubborn. I'm just going to do it when it's easier. Because if I have spectator ions that are out of balance above, do I give a crap? Not really. They're there. Okay, moving on. So the net ionic, it's time to eliminate the spectators. The spectators, tell your partner, well, what two things? All right, they were K and what else? Acetate. Right there. That's pretty far away on that screen. So I am left with the following. I have I minus plus Hg plus 2 goes to HgI2 solid. Now, is that balanced? It's not balanced. So what do I need to fix in the net? I just need a 2 right here, right? So I could balance all that at the start and carry it through. That's the perfect way to do it. Or I can balance the net ionic, which is less perfect, but still the right answer. You guys having fun? I like watching kids flirt in class. He's bullying. You only bully the ones you love. All right. Okay. Who? Raise your hands if you had the bottom line correct. If you had the net ionic, raise your hands. If you had this one right, raise your hands. Okay, we are at half. That's not awful. We're only at half that got it right. No, this is it. I want another example, but I guess we'll just have to write one. All right, I have KOH plus aluminum nitrate. Let's see what you got. So potassium hydroxide. This was really bad writing, I realized, because OH is off the screen. Hold on, let me shrink this part down. Well, oh, I can get them both on there. Thank you. My self-esteem just skyrocketed. Yep, I am glad. Give me someone to yell at every day. Aren't you in the play, Alan? Oh, okay. Mamma Mia is like a week away, isn't it? Oh, never mind. Okay, we can have COVID then. We're writing the full, or the molecular, the complete, and the net. The left. I only had a couple come to the parent-teacher conference, which is fine. How many of you are scared of me? Let's be realistic right now. Blaine? Wow. I'm scared of Blaine. Tiny bit. All you need is right there. That is all you need. What? There will be some, but not on my test and never on the AP test. In the AP test will say, assume all reactions happen as written. So they will make sure they are ones that happen. Okay, so there's all this stuff, but ultimately, please, it's OH minus plus Al plus 3 goes to AlOH 3, and then you got to balance. And that's it. Okay, we're not done. We'll do more, but please, if you can find 15 minutes in your night tonight, which all you kids always tell me, I have no time. Your screen time is like 4 hours per day. What? That's at school? We'll do it next hour then. Try and get on that for me.